Today we are diving into two of the most startling signs you can see in emergency medicine: abnormal posturing. Now these aren't just some random movements, no way. They are very specific distress signals coming from deep inside an injured brain. So let's get right into decoding them.
So here's the big question we're going to tackle. How can the way a person's arms and legs are positioned tell us, with pretty shocking accuracy, exactly what part of their brainstem is in crisis? It's like a clinical mystery, and we're about to solve it by mapping what we see on the outside to the damage that's happening on the inside.
All right, here's our game plan. First up, we'll get really good at spotting these two postures. That's the what. Then we're going to take a trip inside the brain's wiring to figure out the why behind them. We'll look at each one piece by piece and then bring it all back to what it means for the patient, the all-important so what.
Okay, let's start with what you see right at the bedside. In a high-pressure situation, the first big clue can be just identifying one of these involuntary postures. They look really different, and believe me, that difference means everything.
Here they are, side by side. On the left, with decorticate posturing, you really got to notice the arms. They're flexed, bent inward, right on the chest, almost like they're protecting the body's core. The legs are straight and extended. Now look at decerebrate. It's the opposite story for the arms. They're rigid and they're extended straight out by the sides. The legs, they stay extended in both. So the real giveaway is always the arms. So how do you keep them straight under pressure? Well, here's a great little mnemonic. For decorticate, just focus on those letters, C-O-R. The patient brings their arms in towards the core of their body. It's so simple, but it is incredibly effective.
And what about decerebrate? Well, just look at all the E's in that word. D-E-C-E-R-E-brate. All of those E's are there to remind you that the arms are extended. You memorize those two little tricks, and I promise you will never mix them up again.
Okay, so we know what these postures look like. Now for the really fascinating part, why do they happen? The answer is hidden in this delicate balance of power, this kind of tug of war between competing pathways that run all the way from our brain down our spine, controlling our every move.
Now, at first glance, this might look a little complex, but the idea is actually pretty straightforward. This is the brain's command and control system. You have signals traveling down these superhighways or tracts, telling our muscles to either bend, that's flex, or straighten, that's extend. It's a constant push and pull, and when you have a serious brain injury, this whole system gets thrown into total chaos. And here are the key players in that battle. So, you've got the corticospinal tract, that's our conscious, voluntary control. But look at the others. The Rubro-spinal tract. This one is a powerhouse for flexion, especially in the arms. And fighting against it, you have team extension, the vestibulospinal and reticulospinal tracts. Normally, the cortex, our higher brain, is like the referee, keeping everything in balance. But when it gets injured, that top-down control is just gone.
So, let's see what happens when that balance is totally wrecked. In our first scenario, the injury is pretty high up. It takes out the cortex, but crucially, leaves a key part of the brainstem still working.
And this image makes it crystal clear. See that gray bar? That's the injury, the lesion. It's located above a structure called the red nucleus. This cuts off all the signals from the thinking part of the brain, so voluntary movement is out. But, and this is the key, the red nucleus itself is fine. And since the cortex isn't holding it back anymore, it's been unleashed.
So let's break that down. The cortex is offline, right? So the red nucleus is now just free to fire like crazy. Its pathway, that Rubro-spinal tract, just floods the arms with flex signals, and that's exactly why the arms pull into the core. Meanwhile, down in the legs, which aren't really influenced by that tract, the powerful extensor pathways are now unopposed, so they just take over, causing the legs to go rigid and straight. And that combination, flexed arms, extended legs, that's decorticate posturing. But what if the injury is lower? What if the damage actually creeps down the brainstem and takes out the red nucleus itself? Well, this is where we see a shift to an even more serious, more ominous sign.
And this slide shows that terrifying next step. You can see the injury, the gray bar, has moved down. It's now at or even below the level of the red nucleus. So this doesn't just cut off the cortex. It completely knocks out the red nucleus and its entire flexor system. So think about it. If you've eliminated the entire system that tells the body to flex, what's left? Only those powerful primitive extensor pathways, the vestibulospinal and reticulospinal tracts. With no opposition, they completely take over the whole body. The result is that overwhelming, powerful extension in both the arms and the legs. And that is decerebrate posturing. We have covered the what and the why.
But now, we've got to talk about the most important part, the so what. What does all this mean for a patient? Why is telling these two postures apart so absolutely critical in an emergency?
Well, these signs are so important they are literally built right into the Glasgow Coma Scale, the GCS, which is used all over the world to measure a person's level of consciousness. Abnormal flexion, our decorticate posturing, gets a score of 3 for motor response, but extension, decerebrate, scores only a 2. That's just one single point above having no response at all. That lower score tells you it's a deeper, much more severe injury.
And this is the most terrifying implication of all. If you have a patient who was decorticate, and then you see them suddenly shift to decerebrate, that is a catastrophic sign. It means the brain is swelling and is literally being pushed downward, a process called herniation. It means the injury is actively getting worse, moving deeper into the brain stem. It's a top-tier neurological emergency.
This slide shows you that grim progression. As the pressure builds and the brain herniates, the patient's condition goes downhill in these predictable stages. They might start with some basic function, but then they slip into decortication as the injury hits above the red nucleus. Then, as the midbrain gets crushed, they shift to decerebration, and the final stage is becoming completely limp or flaccid as the brainstem fails entirely. Watching this happen is like watching a clock tick down on a life.
Now let's talk prognosis. And honestly, the numbers are bleak. For a patient with a traumatic brain injury who starts showing decorticate posturing, the survival rate is only about 37%.
But for decerebrate posturing, it's even worse. The survival rate plummets to a devastating 10%. This just hammers home why telling the difference isn't some academic quiz. It is a profoundly important clue about the patient's chances.
So if you take just one thing away from all of this, let it be this. A patient's posture is like a window looking directly into their brainstem. Arms pulling into the core tells you the red nucleus is still online, still fighting. Arms extending out tells you that system has been lost. It is anatomy, made visible right there at the bedside.
And that leaves us with one last critical thought. Now that we can read these signs, now that we understand what a shift from flexion to extension really means, how does that knowledge completely change the game in that first golden hour of emergency care? What actions have to be taken right now to even try and stop that terrifying cascade?